Page 100 to 500.
The next assignment is to memorize the first 100 digits of pi.
There you go. Yeah. Why don't we all waste some brain cells, huh? Like, those people that do that to win money most of the time.
Please.
All right, guys. So, if there's no questions from anything, we're just going to jump right back into it. And the very first thing I want to do is, I always forget, we talked about this a couple times now, this fact up here. And we used this fact to figure out the derivative of something. They do give you a few problems to kind of play around with this idea. So for example, if the limit as x goes to 0 of this is 1, what's the limit as x goes to 0 of this?
Still one.
Still 1. Because what's 7x doing? It's going to 0 just like this was. What's 7x doing? It's going to 0 just like that was. So that is still 1. Is everybody semi-cool with that? Because I could even do something, I could even do let u equal 7x. I don't know if you ever seen this. And as 7x goes to, as x goes to 0, so does u. So this obviously is 1, because now it's in the same form. Okay, I like it. So what's important about this statement is that these are related and these are the same. So, what about this? Jen. Put a little x in there. So sine of 5x over 3x. What's obviously wrong about that?
Denominator is smaller, so.
Yeah, 5x is not 3x, they're not the same thing. So I can't apply this idea because the parts there are not the same.
Well, I mean, they are just coefficients to variables.
This is true. I like the way you said that. Numbers don't matter as much. Constants don't really matter as much. You got to keep track of them, but they don't affect things. It's the variables that affect things.
Especially when the variable is 0.
Well, the variable's never 0 though, right?
Limit.
All right, no worries. So look what I can do. Is everybody cool with this if I take a 1/3 out? Isn't that what limits do? Don't they just sort of like come into this? All right, that's not really better though, is it? Because it still isn't the same. What do I wish was here?
A 5.
All right, so what if I put a 5 there? What if I just put a 5? Let me just put a 5, bam! No, I can do that as long as I also do what? What am I allowed to multiply the bottom of something by 5? If I also multiply the top by 5. Overall, did I just do anything? No. So what is this now? 1. And what's this? 5/3. So this limit is 5/3. You can sort of see the shortcut now, right? All right, so you will see a few problems where they kind of throw some different stuff at you. Okay, they do have a few examples. They get a little bit weirder, but they're all basically the same idea at the end, trying to balance things out. So this idea of putting what you wish was in here, we can only do that with numbers, correct? I really want this to make sense. All the x stuff has to stay inside. It can't come out because it's affected by this. This 3 didn't give a shit about what x is doing because it's freaking 3, so it can come out. So this idea of, I wish this was inside this number. Well, put it inside and then outside balance that. So overall, you didn't do a damn thing. Maybe? Maybe. Okay. All right. So that's one thing. I think, yeah, let's do this. Let's remember what we did 2 days ago. Product rule says that if you have a function that is the product of two functions, how do you take its derivative?
F prime of x times g of x
Times plus
g
f
prime
of
of
x
x.
times g prime of x.
11. So it's f prime g plus f g prime. Sometimes I'll maybe not be careful enough that I'll just put f and g, and we all can agree that that means f of x and g of x. Just makes it quicker to write stuff down. And of course, what about quotient rule? Right, I busted out my award-winning song for you guys. I don't know if you remember my little song. It's got a lot of lyrics to it.
F prime of x.
Yeah, what's important? Top first, so the top gets derivative first. So it's almost like product rule, except what goes here?
Minus.
Minus. But it looks a lot like product rule so far, right?
Yeah.
Except it's a minus. Can somebody tell me real quick why that's a minus?
Because then you bring the derivative of g.
Yeah, g was on the bottom. So if I bring it up, it's going to have a negative power that's going to show up there when I take its derivative. Really bringing that in and doing this because it makes sense is better than any freaking Heidi-Lo song you want to have. Now, I'm not saying the Heidi-Lo song is bad. I'm just saying it takes you away from why things work. It makes things feel like, oh, I would never understand if I didn't have this song, which is crazy. All right, I don't know, it's just me. And what's on the bottom?
G
G
squared.
x
Yeah. Quotient rule is kind of gross. Not too bad, it's just the way it is. So, what I want you to do before we do any new stuff, one side of this page has on the top notes on the chain rule section 3-4. Don't look at that side yet. Right? On the back are several problems, and I want you to do A through F. Sure. And I will show you one thing before you get started. If I wanted you to do, real quick, before you get started, I got one thing that's going to help out on one problem. If I wanted you to figure out the derivative of, you can do it, Jeff. You have to use quotient rule. No. Anytime you are given a function and asked to find its derivative, take a second and see, can I simplify the function? Doesn't that make, wouldn't you rather have a simpler a simpler function to work with? So it should make sense. Before I do any derivatives, I want to simplify it if I can. And what can I do, obviously? Anybody? Yeah, I lose 4x, it's still be 4x to the negative 1, right? Is that cool?
Yeah.
Minus 3x to the negative 2. I don't know why I wrote it like this. Plus 2x to the negative 3 minus. Now that's easy as shit, right? It's like 1, 2, 3, 4 terms. They're all x to the n. You could do quotient rule on this and it would be horrific. And it would work. Why would you? So there's one problem. Second?
Because we hate ourselves.
Oh, all right. Well, I'm sorry. Don't do that. Life is hard enough, kids. Don't do that to yourselves. So go for it. You can, if you want to kind of.
This is differentiation